Hi guys, and welcome back to a new video. And finally, we're going to be starting the Rainbow Six Siege drone. So the Rainbow Six Siege drone looks sort of like this, and this drone is just based off of a video game where this drone like spies on the enemy, and I just decided to make it because it looks really cool. Also, one thing to note is it's not going to look the exact same because I don't have the like a 3D printer and the parts to make the appearance looks the same. But I'll be showing you how to make a functional model of it. So now let's talk about the parts that you need for the transmitter. So I will be using the Arduino Mega 2560 as it has many pins. And then for communication, I'm going to be using the NRF24L01. Oh, by the way, you need two of these, but for the transmitter, you only need one. Then we also need an input, which is going to be the analog joystick, which will control the speed and direction of the motors. And then you finally have your power source. So for this, I'll be using this battery pack, and this provides 5 volts, so it can power the transmitter. The reason I'm using a battery pack is because I don't want to carry my laptop with me when I test this. Now let's talk about the parts that you need for the receiver or the drone. So for this, you would need the Arduino Nano. I use this because it's super tiny. Then we have the motor controller. And once again, I'm using the L298N. Um, Also, the receiver needs another NRF24L01 for communication. And then, of course, we need our two motors. And these two motors, I found them on an old toy car. So I want to actually have like a link for these motors, but I will put in another link of like motors that I think will work. And then lastly, we have the battery pack. So here I am using the 9-volt Amazon Basics battery, and I have this like connector that makes it easier to add your 9 volts. And let's not forget, you need a crap ton of wires. Just have a bunch of wires. That's it for the parts. Now let's look at the schematics. So first here we have the drone schematics, and we have our two motors, the 9-volt battery, the L298N board, NRF24L01, our nano. And here's how the schematic goes, and now I will show you a closer one. Pause the video right here to do the schematics. Now let's look at the transmitter schematics. So here's the transmitter. We have our NRF24L01, our joystick, and our Mega. Now I'll show you a closer one. Just pause the video right here. That's it for the schematics. Now that your parts are connected and ready. Oh wait, my parts aren't ready yet. Let me just fix this. Wow, everything is attached. This is amazing. Now, let's go and check out the code. Now let's test both the code and the analog joystick. So let me explain the code. This is only the analog joystick testing, by the way. So here we define the pins. We set the baud rate to 9600, and we just read the analog pins for both the x-axis and y-axis, and the slash in just put it on the other line so that it's easier for you to read. And then now let's upload the code. It's done uploading. Now serial monitor, and here you'll see it. So make sure that the pins are facing the right, and when you go up, it should go to 1023 on the y-axis. And when you go down, it should go to 0 on the y-axis. And when you go to the right, it should go to 0 on the x-axis. And 1023 to the left on the x-axis. So this is a little weird and different from the first video, but for the R6 drone, this is how the analog joystick will work. So remember 1023y, 0y, right 1023 on, 0 on x-axis, and 1023 on x-axis this way. That's it. Now that we have the code on and the battery on and everything connected, let's look at the code. So in the beginning, we define our pins and then we make them all outputs. We make an acceleration function and a deceleration function. And then here, first, it makes the motors go forward, accelerates them, then decelerates them, waits for a few milliseconds, and then goes backwards and accelerates the motors and decelerates the motor. And now let's upload the code. And make sure you're holding your motors up if they have wheels, otherwise they're going to go everywhere. So now you see that they go forward first. And then they slowly start decelerating. And then it does the same thing backwards. But I don't really need to show you that, you'll see it yourself. And when you test this, make sure that this is facing forward and you're holding the motors like this. And test it, otherwise it might come out wrong. And also, if it goes backwards instead of forward, then just switch the polarity here. Just switch black with red and red with black. That's it for the testing the motors part. Now we're going to test the NRF24L01. So on the left side, we have the transmitter code, which just define, and first we start off by defining the pins, and then it just sends a message connection works. And then after that, on the right side, we have the receiver code, which just reads whatever it gets. So now I'm going to upload the code to both of them. On the serial monitor, you should see connection works. If you don't see this, then your wiring is probably wrong and you might want to check that, or your NRF24L01 is bad. That's it for testing the NRF24L01. Thank you for watching the video, and if you had a problem, make sure that you go back and check the schematics one more time and also go through the testing. So the reason why I posted so many codes was because you could use those codes to check every single component to make sure that you don't have a problem. And also the reason I didn't post the code just yet is because I need to do a lot of explaining about it, and that would need to be like a separate video. I will show you like tiny sneak peek of the code running after this, after I talk about this stuff. And also one more thing, if you still have some problems with this, make sure that you go back and check the other videos that has my analog joystick and my L298 board. And if you're interested and do want like a video on the NRF24L01, just comment it down below and I'll make one. That's it for this video. Thank you for watching, and now we're gonna play the sneak peek. We'll go forward, and now when I go backward, it'll go backwards. If I do right, it'll turn to the right. And I did this by making one motor go backward and the other go forward. And then same thing for the left.